For exercise 7, our goal is to determine if pulse varies by activity level. So we're going to use BlueSky statistic to test the assumption of equal variances and normality for the variable pulse by activity level. If the analysis indicates the data are normally distributed and the variances are not unequal, we're going to perform an ANOVA. If the analysis indicates that the data are not normally distributed, we'll perform a Kruskal-Wallis test to analyze pulse. We've loaded our data from the spreadsheet, and we have a number of different variables: gender, activity level, smoke or no smoke, height, weight, and pulse. We want to analyze pulse and would like to analyze it for activity levels. So is the pulse rate between people who have moderate exercise, a lot of activity, or slight activity, does it differ? Go to the analysis menu in BlueSky, scroll to the right, you see variance tests. Click on that and choose Levene's test. We have done this, and here was our dialog box. And we entered pulse as our response variable and activity as our activity level, and I chose median so we could have a little more robust test. We did the analysis by executing that dialog box. Levene's test gave us this output. And first it gives us a lot of summary statistics, but the bottom line is Levene's test for homogeneity of variances says that the p-value is 0.8633, which is greater than 0.05. So we can assume for our purposes that variables, the variance of the three different activity levels is consistent, homogeneous. The next assignment wanted us to test for normality. As you know, I'm very partial to plots and graphs, so I did a PP plot, and we looked at pulse by activity level, put a reference line in there to show us if the data fits a normal distribution, executed the dialog, and this is the output that we got from BlueSky. So we got a single chart. I'll expand that. And it plots the three different activity levels versus the expected probability level. If the data are normal, they'll scatter randomly about this line, which represents a perfectly normal fit. So a lot has a fairly small set of data, but these are the round dots, and you can see that they're scattered fairly randomly around this line. Moderate is a triangle. That's our most frequent one, and you can see these points too tend to follow that line pretty well. And slight is represented by the squares, and they too are scattered randomly around that line. So the graphical evidence shows normality. These are relatively small sample sizes. BlueSky allows us to do separate plots for each activity level. If you go to data sets and you go to group by and you click the arrow, you can choose split, and BlueSky will split the data according to some variable in your file. We've done that, and we told BlueSky to split by activity level. So it will do each analysis once for each different activity level. So I asked BlueSky to once again do a PP plot so we could examine the data for normality, but this time do it separately so we can see a little better what's what. So here's the activity level a lot. There's the PP plot. I like the fit. Next we have moderate activity level. I also like that fit. And finally, we have slight activity level, and I think that fit is also good. But perhaps you'd like some numerical evidence that these fits are adequate. One way to do that is to fit univariate distributions to our data, and in particular to fit normal curves to our data. To do this, go to the Analysis tab, scroll over till you see Distribution Analysis, scroll down till you see Distribution Fit, and click that. We've done this, and we just picked normal. So we want to analyze pulse to see if it's normal. Since we have the split on, BlueSky will do this analysis separately for each activity level. It has done this. So here's our activity level or distribution fit for pulse, activity level a lot. And you only need to look at one statistic here, and that is the p-value for chi-square. So that p-value is 0.2346, which is greater than 0.05. So according to the chi-square goodness of fit test, our data could be normal. We can accept the hypothesis of normality, well, fail to reject the hypothesis of normality. And BlueSky also plots a whole variety of graphics to help you confirm that this data could be normally distributed. Next, for moderate activity levels, and you could look up all these statistic p-values too, but since BlueSky gives you a p-value, chi-square p-value, also greater than 0.05, so moderate data seem to be normally distributed. We'll scroll down past all the additional evidence, look at what's going to happen with slight activity levels. Once again, chi-square p-value greater than 0.05, so this data too, we fail to reject the hypothesis of normality. Now we'd like to do analysis of variance, and we're allowed. It meets all of our assumptions of normality and homogeneity of variance, but first we have to remove the split. Remember, we are splitting the data. So we go to Data Sets, Group By, remove the split. Now we can go to Analysis, Means, ANOVA, 1 and 2 way. We want to analyze pulse, and we want to examine pulse for different activity levels. So we click Execute Dialog, and BlueSky will do an analysis of variance. Gives us summary statistics in an ANOVA table, and the p-value is greater than 0.05, indicating that altogether there is no significant difference between the activity levels and the pulse rates. And we get additional analysis. So we can conclude that there is no significant difference between activity levels and pulse rates. And just for kicks, let's also look at the Kruskal-Wallis test, which we were told we could use if there was a significant non-normality or variances were not equal. So click on that. The response level would be pulse. Factor level would be activity. And we'll execute the dialog. And Kruskal-Wallis gives us the same final result, a p-value greater than 0.05. So we can conclude from either the parametric or non-parametric analysis of variance that the pulse rate is not affected by activity levels.